pretend this is a brand new module, and I'm going to start creating my transaction. So the first thing I need to do is well, set up my network. So we have two isolated Ethernet ports. They have to be on separate subnets, so you can either run everything through one single port, or if you want to segregate your database network from the plant network, you can use them completely independently. So fairly standard network setup. You can use DNS if you want to talk to the database by name and so on. Fixed IP, DHCP. One interesting thing is that we have some diagnostics running on the module. So directly from the module, I can make sure that I can talk to my database server. So if there's any firewall in between or things like that preventing the communication, I can troubleshoot that from here. So the commands are going out from the module itself. And then the only other thing that I would need to set up is my my time, because we can timestamp the data when the transaction fires on the module. So we want to make sure that the clock of the tManager is synchronized with a proper time server. So that can either be an NTP server running on my computer network, like it's set up right now, in which case I can also pass that time down to the PLCs on the network as the destination, or I could do the other way around and read the time from my automation device. So in this case, my PLC would be the time source, and I'm going to synchronize to that. So right now I'm synchronizing to my computer network, and that's pretty much it. From here I can go in the projects. Let me stop this one and create a new one. So like I said, let's pretend this is a brand new module. So I'm going to create a blank project, and if I open that project, then I go in the project editor side of the software. So from here, there are a few things that are automated for you. So for instance, I've got that automation adapter here, and if I open that up, the module is going to actually browse my chassis, find what's in there. So I've got my ControlLogix processor in slot 0. I could go on the network, either using the Logix network cards and go and talk to a separate module on the network. So that could be a CompactLogix, that could be an older PLC from Rockwell, and so on. Or I can even talk to non-Rockwell PLCs, talk to an S7 or some Modbus TCP device directly from here. And you can see by default, all the tags are read-only. So if I have the right login to do my configuration, I can also make those tags writable. So I can go back and, if I go and fetch a recipe, for instance, in my database, I can go back and write that in my PLC. I can go and create a new adapter to my database. So I only need a few things from IT to connect to my database: the IP or the name of the host, the name of that database, and then a username and password to talk to it. Same thing as the PLC, so my connection is correct to my database. I can go and enumerate that database. So the module is going to query the database for what's available. So for my user EATM, I can see a few tables and stored procedure and everything that I can access. So I can select them, and now they're going to be available for my configuration. So from here, I can create my message path. This is the actual transaction. So you can see we can access directly tables, either to store data, so insert or update data directly into a table. We can do select and go get data from that table and send it down to the PLC. Or we can actually call a stored procedure, in which case it's, well, you send data whichever way you want. That trigger. So we have actually three types of triggers. So we have periodic, in which case it's going to fire like every second here, and just fire my transaction. Scheduled is a similar thing, but a bit more detailed. So I could create a schedule like every day at 8 in the morning or something. I want to capture a snapshot of my stock level or something. So I can create it very easily like that. And the third one is event, in which case the transaction is actually driven by the PLC. So the good thing about it is that it's properly event-driven. It's the PLC that has to send an explicit message to the module to generate the transaction. The bad side of it is that it requires that you program that message and potential errors and retries in the PLC. So the next best thing that we have available is using that same periodic event I talked about from the beginning. You can add a condition, so you can actually, for example, monitor a tag in the PLC, and I'm going to monitor that tag in this case every second, but I could go down to 250 milliseconds. And if that tag changes, or we have a whole set of conditions, becomes equal to something or greater than something, I can compare it to something else. That's going to be my triggering event. So this is sort of event-based, and if your process is slower than that 250 millisecond scan time, this is, I think, good enough, and that prevents you from having to write anything in the PLC itself, and the module is just going to manage the transaction. And I mentioned timestamping before, so we have some macros here, and I can just drag and drop that timestamp value here. That's going to be when the transaction fires. So even if there's delays later on, we buffer the transaction somewhere, or we can't talk to the database and so on, that timestamp is still going to be when it actually fired in the module. We have some function block toolbox where you can do some manipulation on the data. So we have a fairly extensive set of function blocks you can use, and it's the same thing. You just drag and drop them onto the map and just connect them together or something like that. So if you want to do some manipulation of the data before you send it to the database, you can do it either in the module or in the database itself. I could actually create multiple endpoints with various configuration, individual configurations. So for instance, for this one, let's say I want to enable the store and forward. This is a buffer. We have up to 2 gig of flash memory on board the module, where we're going to buffer all the transactions if the database is not available. So network issue, database being patched and restarted, something like that. So we're going to make sure that we don't lose those transactions and buffer them on the module and resend them automatically. Same thing here, I could set up the failover. If I've got another alternate database that I can talk to, the module can be set up to automatically fail to the second one after 3 attempts. Then you can set up automatic recovery and so on. So just a matter of checking the checkbox, and that's pretty much it. The module takes care of the rest. So I have my endpoint here, the pieces that I created. So my endpoint, my trigger, my project. And that's it. It's all running now. So I could, from now on, disconnect my configuration software, and the module is just going to execute those transactions. So if I look back at that status window that I showed in the beginning, so we can see here I'm already sending. I've got 9 messages successful that went into the database. It's really designed for the PLC guy. You don't need to write any SQL commands. You can have a look at it in the module itself. It's going to tell you what is the SQL that's actually generated by the module, but you don't have to have any knowledge on that. It's really fairly intuitive for someone used to programming the PLCs. So right now, I set up the transaction without doing anything in the PLC. So the PLC is not even aware that the module is there. But we have what we call the Supervisory Controller. You can set up in the PLC an add-on profile that's going to give some feedback to the PLC on what's happening, so that the module's alive, whether we have data in that store and forward buffer, if the module is in run mode, and so on. And you can also control, with those commands here, you can control the tManager from the PLC. So you could start and stop individual projects. You could start the entire module, and so on. So you get some level of feedback here. And also in each individual trigger or endpoint, we have some status tags that are going to be provided back. All that is optional. That's going to be provided back in the PLC if you want to know what state each transaction is in and what status the endpoints, if we're connecting successfully to it, if we got some timeouts and so on, how many errors we got, how many messages we've got in that store and forward buffer, and so on. So all that extra information is entirely optional, but it's available. So you can decide either in your PLC or on your local HMI to act if you detect that that something is going wrong. I got a UDT in my PLC, and what I want to do, so it's a very basic car example. What I want to do is when that RFID value is changing in the PLC, so I read a new RFID coming in on my line, I want to go in my database, and here I have a set of like recipes based on that RFID number, and get the rest of that data and fill up that UDT in my PLC based on my RFID number. So the way I'm going to do that is same as before, create a message path. But in this case, either, well, I could call a stored procedure and do that, or directly access it in the table. I'm going to call a select. So same idea, a bit more complex because we're going to write back in the PLC. But I've got my trigger. So I'm going to create a trigger that will monitor that RFID value. So when that RFID value changes in my PLC, I'm going to trigger my transaction. In this case, I could reuse the same endpoint. As best practice, we would segregate, have two endpoints, one for reading and one for writing to the database, but just for the demo, we can reuse that. The map, in this case, is going to be the other way around. So my input is going to be the results I receive from my database. So that's all those values here. I don't want everything. And I'm going to write that into my PLC. So I've done that before, so they're already writable, but by default, I would have to make sure that that UDT in my PLC is writable. And I just drag and drop my tags on there. So same thing, I could use the function blocks, or I can just connect them directly. Also, we have some added macros here. I've got a row count, so we can, in this case, I'm writing into individual tags, so I'm going to be able to read only one recipe at a time. But if these were arrays in my PLC, I could go and get several of them at a time, in which case I'm going to get the number of row returned by the database, and I can fill up that array. So I want to make sure that I know how many results I've got, and also in the transaction, we'll see in a second, I can make sure that I don't overfill those arrays. So I want to make sure that that max rows returned is equal or smaller than the size of my tags. So in this case, they're individual tags. So I want to make sure I get only one result. So I get my map. I need an endpoint on the automation side because I'm going to write back in my PLC. And then the where clause is what data I'm going to look up in the database. So in this case, I want to look up the record that has the RFID value equal to my PLC RFID here. I can add more things here and combine them, and or I've got a bunch of operator available to create my my lookup clause in the database. So right now I'm just going to look out for that RFID value. And if I get multiple records, I can also order them by a criteria that I choose. But in this case, I'm only going to read one recipe. Save it. And same as before. So I start my triggers and endpoint and so on. And now I can go and call that thing from the PLC. So if I go in my PLC and change my RFID tag, it's going to look up in the database and fill up those tags here. This is what I have here, Toyota, and those are the values that I got back. You can also define, for my recipe here, a status tag here that's going to tell me what state of the transaction I'm in. So you can do the complete handshaking on the transaction. So that value is going to be refreshed in real time in the PLC as the transaction executes. So you know, for instance, if you get a 10 in the PLC, that we read the data from the PLC and we're got it in the module, in queue if it's stuck in the store and forward queue in the module because we can't talk to the database. 30 once we sent it to the database, and then we got the response back, 40, and then 50 we sent the results back into the PLC. So you can control, or if it's 100 something, you know there's an error or something in the transaction, somewhere in the transaction. So you have complete control over, you will know once you got the entire response from the database, and it's been mapped into the PLC, and now you can move on and do whatever you want in the PLC. So you have those various level of feedback. We even have now like an advanced status tag, and that's going to provide even more information such as timing of the transaction, so you can monitor if your transaction takes longer than expected, and so on, number of errors that have happened, and so on. So you have a lot more control in the PLC itself without having to use our configuration software to go and monitor here what's happening. All those values here, and those you can get more detailed timing information on the transaction. That's all going to be available on those advanced status tag. So here you can see everything that's running on the module. I've got multiple triggers, I've got multiple endpoints, number of good transactions, if there's errors, the timing information on the transaction, and so on. So you can see here we've got a system and an audit log that's going to store all the information on what's happening in the module. So you can see here my error was here, and this is because when I downloaded the program to the logics, the module couldn't read that value from the module. So you can get all that information here. Or you can export that log automatically to either to an FTP site or as an email attachment. So the system log is going to store all those errors and everything that's happening on the module, and the audit log is going to store everything that I do as the connected user on the module. So with my username here, it's going to store that I created transaction, that I started things. If I delete, so I created that message path. If I delete things, it's going to show up there. If I stop things, and so on. So you can monitor exactly who's done what on the module, and either, again, look at it here or export it whenever they fill up. So there's like a cyclic buffer. We've got 20 log files of 1 meg each, and as they fill up, we can export them automatically, and then they get overwritten when the full 20 files has been written. I talked about multiple users before, so you can create users with a fairly detailed set of roles that you can assign to them and restrict access to certain things or not. In terms of maintenance as well, very similar to a PLC, so you can back up and restore into one single file, so a single operation for the entire configuration of the module. So similar to upload, download to a PLC, and that makes maintenance very easy. So instead, if you have a PC, to bring in a new PC, re-image the OS, maybe the software, reconfigure the software and the connections and all that, this is just a matter of restoring your backup file onto the module, and it restarts where it left. So very fast and very easy to manage here. Set up that AOP so I can see those values now show up in my PLC. So it is defined here in my slot 1. I've got my tManager. So we use a generic profile. It's fairly simple, but you get that information, that global information on how the module is performing, and you can control it as well. So you can see here in your I/O information. In the output, you can control the module, so you can start, stop the module, start, stop individual projects, and then in the input, you're going to get information on if the module, if there's an error, if there's data in the store and forward mode, if the module is in run mode, and so on. And that free running counter is going to be like the heartbeat that the module is working fine, and you can make sure that everything is running. In my transaction here, instead of doing a direct like table access, I can call a stored procedure. So same thing, I got my trigger, I got my map, and my stored procedure. The only difference here is because my stored procedure can have input and output parameters, my map is a bit more complex. So I have, for instance, stored procedure here. Let me get one with outputs as well. And I just drag and drop my stored procedure definition here and create my map, same as before. And then the outputs are going to be here. With the database connectivity, we can't really push data from the database down to the PLC, so you'd need to set up a transaction that would be periodically checking on the database, either on the main table, or if it's a really large table, maybe you want to have a small temporary table that you go and query regularly from the module, and if there's new data, then you fire your transaction and go and fetch the big data set. We do have adapters for non-database connections where you can do that, actually push data from, so we have a JMS and WebCRMQ adapters where the IT side can actually push data down, but unfortunately on the database you have to pull it periodically yourself. Like we've got customers as well that go and get like a shift worth of data in the first read and fill up those arrays in the PLC with all the data for the next 8 hours. So even if there's an issue with the database, they've got that buffered up in the PLC. And similar to what I was saying, like if you do select, you can fill up arrays in the PLC. I forgot to mention, if you do a stored procedure, you can set up a record set and return, same thing, multiple results or multiple recipes at once and fill up those arrays, either through the stored procedure or through a direct select. You can set up store and forward as well. So you could buffer, let's say, like, and maximum would be 200 meg of data. So you could read the entire like shift or whatever from the database and store it, buffer it in the tManager, and then using that flow control thing, you can like release messages one by one. So there's like a request and response tag in the PLC that you have to manage, and that would release the results one by one to the PLC. So you can buffer it in tManager itself or in the PLC. That example here would be more suited for like a bunch of sequential build orders or something like that, and you'd release one by one. There's no black and white answer, unfortunately. It depends a lot on how loaded is the network, how loaded is the database, how loaded is the PLC, and so on. But just to give you an idea, let's do it a couple of times and see the results. So if we look at timing here, you can see for a round trip for my recipe, we're about 150 milliseconds. Well, the first time took a long time because it establishes the connection, so that's why the average is fairly high, but it takes about 6 milliseconds or something like that. We've done some projects where we fetch like really large amount of data, and we're second sort of timing is what we're looking at. So we have actually an application note that explains how to set it up. In this case, because you can control the module from the PLC, you would need one PLC to manage that. So one PLC could monitor two modules and then start and stop one or the other, depending on how you want to do it. And we also function in a redundant control logics architecture. So you can have multiple levels of redundancy. You can have redundant CPUs, redundant tManagers, you can have redundant networks as well, and so on.